Hello, everyone. Welcome back to yet another episode of the Forever Forward podcast. And today I have David with me. Hey, David, good afternoon.
Hi, Umesh. How are you?
I'm good. I'm good. And David has a wealth of experience. Once again, I was just going through his LinkedIn bio, and actually, that's when I realized, when I seriously took a look, that this man has a lot of experience on smart building, sustainability, and environment, and everything. So it's really great for us to have him here, and we're going to talk about a topic today, which is, I wouldn't say which is hot, but it's kind of relevant, but it's been around, and something that David knows a thing or two about. We're going to talk about the sort of a guide to retrofits from the perspective of moving from gas to electricity, which is, I suspect, very relevant for Australia and probably markets like UK as well. But I mean, maybe we'll delve upon that as well. Dave is currently in, runs his own consulting firm, and probably, in his own words, probably is doing the work of his life, something that he always wanted to do, and he has amazing experience leading up to what he's doing. So David, I'll probably pass it over to you. Maybe let you introduce yourself and talk about everything that you've done in the past to what you're doing right now.
Hi, Umesh. Well, I won't try and cover everything that I've been involved in. That would be, I think, quite boring for the listeners. But look, yeah, I've been a consulting engineer now for about 35 years. I'm chartered in both structural engineering and building services, so a real multidisciplinary background. And I've worked in the UK, in Melbourne, and then for the last 9 years, I've been in Sydney. And I suppose for the past 20 years, I've really specialised in sustainable design of buildings and infrastructure, but always coming at it with that engineering and technical mindset. I was the principal technical author of the first Green Star rating tool in Australia back in 2003, and I've been the chair of the Green Building Council's technical advisory group for the last 8 to 9 years, overseeing the sort of new suite of Green Star tools. And there's a big focus there on how do we electrify buildings, how do we get gas out of buildings. And yeah, after 15 years as a partner in Cundall, I set up my own practice, Positive Zero, last year. So yeah, about almost 1 year in, it's going well. So I work with developers, architects, building owners, facility managers, to deliver sustainable buildings. But I also work with government and with the Green Building Council to set standards and write guidance for industry. So that's a bit of a snapshot. I've worked on a lot of buildings of all shapes and sizes over the years.
How's the 1 year of entrepreneurship coming along, David?
Sorry, what was that, Umesh?
I said 1 year of entrepreneurship. How's that coming along? You mentioned it's on.
1 year's going well. It's been busy, and a very significant part of what I'm doing is on electrification. So the topic we're talking about today. So yeah, writing guidance with the Green Building Council on new buildings and existing buildings and how do we electrify them.
Right.
Writing guidance with the Better Building Partnership for facility managers and asset managers on how do you look at electrifying a portfolio.
Right.
Currently working with the ACT government here in Canberra to look at how do you help tier 2 building owners, so not the top end of town but the next level down. How do you help them electrify and get gas out of their buildings when they don't have big sustainability teams in-house dedicated to doing that? So there's particularly in Australia, there's a lot going on in the electrification space, and yeah, I've been involved in quite a bit of that.
Awesome. It seems like it's going great. So that's how let's dive into the conversation. So you spoke about a lot of your work personally being around the movement from gas to electricity or electrification of buildings. Break it down for us, like how easy or difficult it is to move away from gas when your systems and infrastructures and mindset has been on the gas for so long.
Well, I think in new buildings, mindset is probably the only real barrier
Barrier.
there. You know,
That's in new buildings.
new buildings, it's pretty easy to get gas out of buildings. You just don't put it in the first place. So just design your buildings to be all electric. The domestic hot water is pretty straightforward. Space
Hmm.
heating, lots of technical alternatives there using heat pumps and variable refrigerant volume systems. So there's lots
Hmm.
of opportunities. Cooking is a harder one
Hmm.
with tenants. Getting your food and beverage retailers to use electric cooking rather than gas is not a technical challenge. That's a mindset
Mindset challenge.
challenge.
Hmm. Hmm.
But again, there's a lot of work going on in that space. There's organisations like the Global CookSafe Coalition that are providing sort of guidance on that. So I
Hmm.
think over the next 5 to 10 years, you'll find that cooking with electric and induction cooktops will be the norm, and using gas will be seen as a thing of the past, in the same way we used to cook on wood stoves in caves. Gas cooktops are going to be looked
Probably the
back
same.
upon as a fairly archaic way of cooking. But
And
at the moment, people like cooking on gas, but anyone that's moved to induction doesn't want to go back.
yeah, so and that's makes sense. I mean, and that's on the domestic front. But like for example, when you talk about the auxiliary systems like hot water systems, as far as the large buildings are concerned and heating is concerned, uh, is that also a mindset barrier for people to change in the existing buildings? I mean, sorry, in the new buildings.
Look, it's I suppose it's habit, isn't it? People are used to designing things a certain way. So when you come
Hmm.
to do your next building, you want to design it the way that you've always designed buildings. But if the if the client briefs there's no gas, then you design it without gas.
You design
Heat
it
pumps,
accordingly. Yeah,
you
yeah.
design it accordingly. Yeah. So um, it's not that difficult to design with heat pumps. And if you didn't have gas available at the building, you would design it without gas anyway. So, I don't see there's real technical challenges for new buildings to be run
Hmm.
off all electric. There's some specialist uses in some types of buildings where that might be
Hmm.
more of a challenge,
Hmm.
but they're relatively small uses. It's only when you get into heavy industry but that's a different
But
conversation.
that's
That's
it,
not
yeah.
that's not buildings, then that's sort of manufacturing
So,
processes.
so all you're saying is
But
that for the new building, it's just a mindset barrier. Technically, financially, you're not really looking at something that it can't be crossed. Is it very
it,
different for existing buildings?
yeah, look, existing buildings is a challenge because you've already got the infrastructure
Hmm.
in there. You've invested in your gas boilers, your gas pipes. If you've got a space heating system using gas, it's very often designed for sort of 80-degree, 60-degree flow and
Hmm.
returns. Certainly in Australia, that's fairly
What it?
standard. And when you
Hmm.
want to switch to heat pumps, you're working on lower temperatures and a smaller temperature difference, and therefore your pipes and your pumps and your coils may not have enough capacity. So
Hmm.
it's not just a case of taking the gas boilers out and putting in heat pumps.
So it's a
It's
distribution
also
that needs to be
that
changing as well.
distribution system, and and
Hmm.
and, and that's probably one of the biggest challenges. At the same time, they've probably been over designed.
Hmm.
Buildings are, when you're designing buildings, you often build in a bit of redundancy. If you put in two gas boilers, so you've got 60%
Hmm.
redundancy in the supply, where with heat pumps, they come in smaller modules.
Right.
So instead of two gas boilers, you might have 5 heat pumps.
Hmm.
So, you don't need to over design the heat pumps.
Hmm.
If you look at you've got an existing building, so you know what your gas bills are. If
Hmm.
you've got thermal metering in there, you know what your heat demand is. probably work that out from the gas bills as well.
Right.
And so you go, well, let's say it was designed for a megawatt of heating. Is it actually really using
A megawatt
that?
of heating. Yeah.
Do I need to take the gas boilers out and put heat pumps in for exactly the same capacity? Or because it's an existing building, should I just put heat pumps in to meet the demand? And how can I reduce the demand in that building?
Hmm.
When is that peak heating occurring? Are there opportunities to reduce that, to save
So,
energy, and to save the amount of heat pumps I need to put in? And then with all of that, can we then make the existing pipe work a bit harder? You might have to change the pumps, you might have to change the coils, but can you make the pipe work a little bit harder because it's already there rather
so
than replacing it all?
So what I'm hearing is obviously, I think one common thing for existing and new buildings becomes is going back to the basics and the design once again and just trying to take a look at it. But obviously things are more difficult, understandably, because of the existing infrastructure that is there. But I heard design a number of times. I'm just curious to ask this follow-up question on this. Does a lot of onus then goes back to design and designers and architects who are kind of, as far as the new building is concerned, or you say no, it always comes back from the brief that the customer gives to the designers and says this is what, like from the new build perspective, is it like
From the new build, some architects and engineers will challenge the client to say, why are we putting gas in the building?
hmm,
But most of the time, people will design what is in
what
the brief. So
got
the
it,
starting point for a new building is don't put gas in this building.
got it.
Yeah, and then that makes it very easy for everybody, and you're designing that from day one. I see it's in Sydney, which is in New South Wales, in Australia. They're about to introduce some new regulations that come into effect in a couple of months.
Mm-hmm.
And for certain building types, which includes offices and hotels, when you put a development application in, you have to either say you're not using gas, but if you are using gas, you have to design the building so that you can take gas out within the next 10 years.
Okay.
So you have to design the space and the ventilation and the electrical infrastructure as if you were going to
You
put heat
would,
pumps in.
so that's like,
And you
got
have
it,
carbon offsets for 10 years worth of gas for doing so. So you're allowed to put gas in. The question is, why on earth would you?
because you're already putting the infrastructure because
You're already putting the infrastructure. Yes, exactly. And you go, and if legislation changes that says you've got to take gas out of the building in the future, all that gas equipment is still going to be pretty new.
I mean,
So
exactly. Yeah, got it. So I think in this case,
and
the
it's going to
legislation might as well do the trick.
yeah, it's going to devalue your building as well, because if you want to sell your building and somebody knows that they're going to have to replace all this equipment with all electric, they're going to
Right.
factor that into the cost of the building.
No, that's a brilliant point. I mean, so just moving on from there, like again, and especially you said that you interact a lot with the tier two sort of developers or like asset owners versus the tier ones now. How different is the conversation when it comes to moving from gas to electricity? One of the points I think you mentioned is that obviously tier one has access to sustainability teams or that intellect capacity or engineering capacity, but would love to know more how different are the conversations.
Well, actually, this is a bit of a, I suppose, a bit of a challenge at the moment, is that I haven't done much work with the tier twos because the tier ones are just making this
Happen.
transition. So two
Hmm.
years ago, you would have difficult conversations about gas versus no gas, whereas
With tier one, with tier one.
there was still gas
Hmm.
going into buildings and gas going into development. And over the last 18 months,
Hmm.
that has completely changed. And it's just, we don't put gas in our new
Okay.
buildings.
Hmm.
But that's at that sort of tier one. And that's partly driven by the larger developers having corporate ESG targets and committing to, we're going to be zero carbon by 2025 or 2030. And saying that you're going to be zero carbon, then putting gas into a building and then buying offsets
Doesn't
for
make
that
sense.
gas use does not cut it with anybody anymore. So when there's
Hmm.
an alternative, which is eliminate the emissions rather than
Offset it.
offsetting, is fraught with all sorts of um, issues, credibility being one of the major ones. Um, so that's what's happening there.
Hmm.
The tier two are not necessarily got those corporate targets and commitments
Right.
yet. So that's where I suppose legislation and policy and those sorts of drivers are needed to
To make
help
that
push it.
happen. Yeah.
And this is something that um, I'm working with the ACT government in Canberra at the moment. They've recognised that the tier ones have got various sort of policies and processes in place. But if you're going to try and electrify an entire city, which is what they want to do in Canberra by 2045, they want to get gas out of all of the buildings, then you've got to have conversations with
Right. You
smaller
can't just
building
limit
operators.
yourself to tier one because that's not obviously they don't make the 100% of the city. I mean, which is true that.
Correct.
Yeah.
So we're about to start in the next couple of months putting some guidance together.
Hmm.
So maybe in about 6 months' time, I'll have a much better answer to your
Tier
question
two.
about
No, no
how
worries.
are
But
they how are they responding. But one of the big challenges is, because they don't have big in-house
capacity.
teams
Yeah.
doing this, they're relying on the advice from consultants and so on. And a lot of consultants are still not up to speed with this yet.
Hmm. Hmm.
So
Hmm.
and that is a challenge in the
Industry.
industry, is making, how do you upskill everybody so that instead of saying this, this can't be done,
This is
um,
how it can
you
be
know,
done. Yeah. Or
this
you.
is how it's done. So if you're a client and you ask a consultant, I want to electrify my building, and they say it can't be done, I think you should turn the question back onto them and say, is
How
it
can
is
it be
it
done?
can't be done, or you can't do
Can't
it?
do it. Got
So
it.
quite a difference there.
Right. No, you can't design it up. That makes sense. But that at least just take a note makes sense for me to come back to you for 6 months later and do another episode and just
Yeah.
talk on that tier two experience. But moving on, I mean, and just maybe taking a deeper conversation on how to, because as you mentioned, the challenge and this is all rest of the conversation is all assuming someone's made up their mind that they want to retrofit. Like in this episode or this discussion, we are not trying to make a case for the retrofit, right? So let's say if someone's decided, whether it's a tier two, tier one, operator or investor, they've decided that really that they want to move on from gas and move to electricity. So what we want to know is that what kind of a framework could they be looking at? I mean, and so one of the first question is how and where do they reassess everything? And maybe this is largely from the built, not the new built, but the existing built environment perspective.
Yeah. I mean, it depends if you like you're talking about in one building or a portfolio. I mean, the questions are pretty much the same. The first
Same.
thing is to ask, where is gas used? Are
Hmm.
we using gas in our building? What is it used for, and how much gas is being used in
Used.
comparison to the overall building? Because from that information, you can get a pretty good idea of the scale
Hmm.
of the challenge. And it sounds like a really easy question, but there's a lot of portfolios don't necessarily know what gas equipment there is
Hmm.
in their buildings, and gas might not be used by the landlord, it might be used by the tenant. So it might not just be a case of saying
Hmm.
what are our gas bills, because some of the gas might be used by tenants, particularly in cooking and so on. So I suppose the very first step in any process is understand
Being
where it's
used.
being used, and you could often find that from your drawings, obviously
Hmm.
your gas bills, and then go and have a wander
The
around the building and work out where it is being used. So, I mean, other things to be thinking about. It's an existing asset, So you've probably got an asset plan for it. When are you planning to do a refurb on it? So are you planning to do a refresh of the building? How old is it? So is the gas boiler coming to the end of its life in 2 or 3 years' time? Well, that is probably the trigger to, if you've got, say, two
That's an
buildings,
interesting
one
point.
gas
Yeah.
boiler coming to the end of its life, another one's got another 5 years or 6 years. You'll do the ones that are coming to the end of their life
Sooner than,
first.
yeah, makes sense. Yeah.
Yeah, you can't do everything all at once.
True that.
You know, we might need to do everything all at once, but we can't do that. We have to be realistic about what can be done, and you want to pick the low hanging fruit and go after the easy stuff as quickly as you can. Yeah. So other things like leases, you know, when a major lease is coming up, that can be an opportunity to do the work in the building.
Or a renew of your lease if someone's
or the renewal of a lease, yeah. And also, you know, electric vehicle charging. If you're looking at providing EV charging in your building for your tenants or your residents or whoever it is, you know, if you're looking at electrifying your building, and you might have to upgrade some of your electrical capacity, you might not, but if you did, you want to look at all this together. So if you're adding EV charging at the same time and you're adding solar panels on the roof, look at all of the works that you might be doing in one go, and make sure you design your electrical infrastructure for that, so you're not doing it piecemeal. You can stagger the works, but make sure you do your electrical works so you've set the building up for all the upgrades as you go forward, rather than doing the electrification and then coming back a year later and upgrading it again for the EV charging, and then a year later upgrading it for something else. It'd be good to have a plan for the whole building as part of your asset.
So interesting. I think one of the points that you said is pretty interesting. I mean, I'm probably didn't through. It's like, look for those trigger points and how soon or how far are they. So, for example, a couple of them when you talk about your lease, but also you spoke about asset life cycle, and so where exactly is it sitting? I mean, those could be important trigger points to decide if someone has a portfolio, which one do you move on first,
Correct.
versus saying that I'm going to take all of them, because you can't literally do all of them together. I mean, in that sense,
yeah, and you've got to stage these things, and that's part of it. I suppose doing a feasibility study, you need to look at each building will have its own unique challenges and opportunities. But a lot of the technical issues will be common across the buildings, but you know, where you put equipment is obviously going to be unique for each
depending
building.
upon how it's been built and so on and so forth. Yeah. So that actually brings me to the next question. You spoke about the feasibility study. Now, and maybe you could give this answer basis not tier one, tier two, but basis the skills that you've seen while through your interactions. Is this feasibility study like you know, when you say, Umesh, you know, just take a look at your gas bills, and they sound like simple things to do in the initial part of it. Like, you can take your gas bills, put them together, see what your consumption is, so on and so forth. But rest of the kind of framework that you've kind of laid down in terms of trigger points, going back to your designs and stuff like that, is it an exercise that someone could do their own, or that's where the consultants really come into play? And so this is where you really bring in a consultant and say, sort it out for me in terms of give me a roadmap.
I would like to think that portfolio owners could do this
themselves
in-house. But if it's the first time, and for most organizations it's the first time because everyone's really sort of starting on this journey, you're probably going to need some
guidance
support initially. But in getting that support, you'll be wanting to say, well, can you, as you're doing this, if you do one or two for me, can we also do some training so that a large portfolio, you want the facility managers in those portfolios to be being able to do quite a bit of the legwork, rather than, you know, paying for a consultant to travel around to all the buildings and all the costs that incurs.
Yeah, that's a major cost.
And the reality is there's just there would be too much work to do for that to all just be outsourced. I think a lot of this can be done in-house. Certainly that feasibility stage. Yeah, because if you look at your building, it's what's the electrical capacity. So what's the peak electrical demand in the winter and in the summer, compared to what the capacity of the building is. So I need to put some heat pumps in for space heating and for domestic hot water. Where could I put them in the building? You ideally want them to be very well ventilated, preferably rooftop, because they work a bit like cooling towers, vertical discharge. You can do them in plant rooms horizontally. They're less efficient there, but that may be the only opportunity. So where can you put the heat pumps? Where's the space for them? Where's the ventilation? You'll typically need some storage tanks. Certainly for domestic hot water, you'll need storage tanks. That can be relatively small. For space heating, you'll want some sort of buffer tank typically. If you're putting the heat pumps in places, you might need to look at getting a planning approval. If it's has a visual impact, you might need a structural check if you're putting it somewhere that wasn't originally. These things aren't that heavy, but they still need to be checked. If it's next to an adjacent building, you might need to think about, acoustics issues. They're all, I think, relatively easily solvable. The main challenge is, where are you going to
put it? Like, where's the space? So that's infrastructure. Where is that going to go into your existing building is what goes in.
And any storage tanks don't need to be located next to them, but they need to be ideally
not far
nearby. And I suppose that's where you need your engineers to get creative. So you
slightly creative,
start looking for the space. You can use rules of thumb. A typical rule of thumb at a design stage is you'll need 4 times the area for a space heating heat pumps than you would for gas boilers. But then it's not quite as simple as that, because heat pumps are quite modular, so you don't have to put them all in one row. If you can't, you can split them up and fit them into spaces. And when you're talking about existing buildings, you sometimes need to be a bit creative and work with the constraints that you have. But it would be pretty rare to say it's impossible to do anything. If you have to do it, then you'll find a way of doing it. So there's always a solution. It's whether that is viable for a particular building or a particular owner at that time that's where you start getting some costings done. But the first step is, how many heat pumps do I need? Where would I put them? What's the electrical load? All those things can be done using sort of rules of thumb and build up across a portfolio where the opportunities are. Then you can build up a business case, orders of magnitude of cost, and at that point you then go in to get somebody to design it for you, because then it gets into the technicalities of delivering it. But that's certainly, that feasibility study does not need to be super technical, but it needs to be technical enough to identify what the issues are, to then form a brief for somebody to take it forward.
So you're saying so what you're recommending is that the first step is to get a brief feasibility study done. It does not need to be a complete end-to-end technical document, but yet it needs to have certain level of technicalities taken into consideration. So let's say if someone gets this, but maybe as a recap of the framework. So one, you're saying, look at the triggers. First collect all the data that you can, which is readily or should be readily available, which is your bills, your design, where all gases is being used, how it's being used, equipments and assets. The second is for you to look at the trigger points once you have this information, and say, okay, what assets are going through or probably going to go through the asset life cycle, so on and so forth. You have renewals coming up. Am I talking about a new lease? Because they could be great trigger points for you to then get better prices, so on and so forth. And once you have those trigger points plus the initial data available, engage with a consultant purely from the guidance perspective, not from the groundwork perspective, if you have that team available, but get a real sensible feasibility analysis done in terms of how feasible is it going to be for that particular building to take gas out and move into electricity. And when we say how feasible, not just saying that yes, it's feasible, but actually having some basic thumb rules mentioned. Here's where the equipment's going to go, likely this is what likely needs to happen, so on and so forth. Is that what the feasibility document would have?
Yes, and then that would then also has then the brief of what needs to then be further investigated, because it will identify what information you didn't have that will be needed. But you, instead of just saying, can you give me a design to get gas out of this building, you've done the starting point is to work out what's likely to be needed, and then you can create that brief.
So what you're saying is that brief becomes the brief to the designers and say, here's the feasibility study, here's what the study said, this is your brief, now help me with the design or whatever provisions that are needed to be done. And in that sense.
Yeah, because you're then going to have to start looking at doing detailed calculations, looking at how you're going to connect it up. I mean, there's other, because the feasibility study might identify you've got a real problem with your electrical capacity. So there then might be an exercise. So what can we do about that electrical capacity before we start designing all of the heat pumps? So and it's looking at where are the opportunities to shift that peak demand. So you could be looking at more thermal storage so that you're shifting the peak demand so it doesn't all coincide. You look at if you've got other systems in the building, how can you control those a little bit better? If you're looking at preheating your building, you do it sooner. You want to look at where the electrical cost is.
So you're basically saying that once you've done the feasibility, there's also a natural extension to demand side management and looking at those concepts. I mean, don't want to delve deeper, but you're probably suggesting that all can be well thought of at the post feasibility study and at the design stage. Is that what your recommendation would be?
I think so. Yeah. If you have an issue with electrical capacity, you might not have a problem because your cooling load might be so much more than your heating load that shifting your building to all electric heating is still well below the capacity that your chillers have. So again, it's just you're not just adding things on, you're looking at the time of use is going to become more and more critical in buildings as we go forward, because as we get more and more renewables in buildings, and particularly solar and solar farms generally, this is certainly what's happening in Australia, is because we've got so much solar and rooftop solar, in the middle of the day, electricity prices are often negative. The wholesale price of electricity is negative. You have to pay for something.
So literally paying people to say, please consume.
Take it. So but then it goes up quite a lot at 4 o'clock in the afternoon as the sun goes down. You've still got wind, you've still got other renewables.
Famous duck curve, as you would say. Yeah.
The duck curve is very much in evidence in Australia most days, even in the winter. So thinking about batteries, thinking about buildings as batteries. So how can a building that's using electricity store that electricity to use it? You bring the energy in when it's cheap, use it, and use that stored energy. And energy storage doesn't necessarily mean batteries. It can be thermal storage. Chilled water storage. We're talking, heating hot water storage. So these are all things to start putting into the
detailed design stage. But yeah, that makes sense. But again, I think you've decoupled what can be going into feasibility study. And I think one major takeaway is that your feasibility study does not need to be a very detailed design document, but a precursor to what you really do in a design stage, in that sense. So I think that's there. I mean, I think, and you've also explained what needs to be done once you have the feasibility study. That's where your commitment comes into picture and say, okay, are you now committed to saying, okay, let me take that next step in my sort of a decasification kind of a journey or electrification journey
Yeah.
in that sense. Uh, Thank you so much, David. This was awesome. I mean, I think the framework looks pretty clear. I think, and just as a recap, maybe for the listeners, you've get your data, builds everything together, get your design, I mean, initial drawings and stuff, figure out where gas is being used, look at any of the triggering points, which could be asset life cycle that's coming through, renewal that's coming through, refurbishment that's coming through, or any new initiative that you're planning. You could be planning around putting in EV, charging infrastructure and stuff like that. David's recommendation is take a systems approach and don't take a sort of only a myopic approach in at least when you're moving in from your mindset of moving from gas to electricity. And once you would have done that with a fair bit of design perspective, not a very detailed, you would have a good enough feasibility study that could form the precursor of everything you do sort of going forward in that sense. So that's a pretty clear framework. And David will definitely come back to you in 6 months' time and just check how things are going from the tier two, tier three perspective. But thank you so much, mate. Really appreciate your time. It was a pleasure talking to you. If there's any passing comment that you would want to make before we say goodbye to our listeners.
No, look, well, thank you very much, Umesh. I've enjoyed the chat, and I think the main message I hope is this is not as hard as it sounds. Just give it a go, and don't do some preliminary work, suss out where the challenges are, where the opportunities are, and then just get on with it, because we're all going to do this over the next 10, 15 years. So the sooner you start, the sooner your building is ready for the future.
So as Nike says, just do it. That's what David's saying. Thank you so much, David. And thank you so much to the listeners for tuning in. Goodbye until next time.
Thanks, Umesh. See ya.